invertible functions. I repeat, we'll start in less than 5 minutes. Repeat the concepts that we discussed yesterday. Sorry, revise the concepts that we discussed yesterday. Especially concentrate more on onto functions. I told you certain steps, right? Revise it. If there is any doubt, please ask questions. And followed by which we'll go for composition of functions and invertible functions. Last exercise of this chapter. I'll tell you. Just give me 5 minutes time. In the meanwhile, shall we get started? So you were asking how to prove that a given function is onto, right? So what were the steps I gave you? Did you write down the steps? I'll try to explain them. So I want you to tell me one by one. So first they will give you, so I want everybody to listen. They'll give you a function with the domain and the codomain. Okay. After that, first step, what are we supposed to do? We need to assume f of x is equal to y, where x is what? Independent variable. Y is the independent variable. I hope this step is clear, right? Then what you will do is solve for x in terms of y. Am I right? So once you do that, you will get x is equal to f of y. Then in this step, after this step, find domain of f of y. So what do I mean by domain of f of y? For example, I get an equation like this: x is equal to y minus 1 by y minus 2. Tell me what is the domain of this. So y belongs to, you should write y belongs to all real numbers except 2. How did you eliminate the 2? Because it's a rational function and the denominator should not be 0. Other logic. So r minus 2. If this domain, if the domain of f of y is exactly equal to whom? Codomain of f of x. I think I have told already. This step is only for your understanding. Exam use. Don't use it in the exam. Okay. If this is equal, then what will you do? You will proceed with the next step, stating that you will take the value of x and again put it back in the question so that you will get f of x is equal to y. If this doesn't work, what will you say? It is not an onto function at all. Okay, that is what you need to. The same thing is applicable for range also. What I'm trying to say is the domain of f of y is the range of f of x. Somebody told me yesterday that they solved problems based on range using the same procedure. Did anyone else try this kind of problem last year? Have you ever solved problems based on range? Range of a function? No. So these are the exact steps you need to follow for range. If you want, you can write it down also. This will help you. This knowledge will help you in calculus part. You will be better. I'm not saying it is going to help you for CBSE, but you will have a better thought process compared to your peers. That is what I'm trying to say. If you want, you can make a note. Make a note stating that this is the same way you find the range of a given function f of x. Okay. So what is it? Domain of f of y is exactly equal to what? is equal to codomain of f of x that onto context. Range la keta. This is in the case of onto function. Seriya? So onto what are we talking about? Codomain should be equal to range then. Okay. So if at all the problem is based on range, till here the steps are same. Then what you will do is domain of f of y will be equal to range of f of x. That is what I'm trying to say. So same steps, but last step alone you will present the answer with a different context. Freedom. Are you able to understand? Those who are online, are you able to understand?
Yes, sir.
Perfect. So shall we proceed to the next part? Right, having this knowledge, we will try to understand what will happen if you have more than one function and you're supposed to combine them. This is a very, very important question. See, the logic is very simple. See, you are actually, without your knowledge, you have been learning functions right from your 9th standard. I'll tell you where. P of x is equal to a naught x square plus a1 plus or a1x plus a2. You would have seen questions like this. P of minus 2 is equal to how much? What will you do? So actually what you did is, at that point they didn't give you as f of x, they gave it as p of x. It's a polynomial function. We have already learned it. So from now we are clear, wherever you have x, and if they ask you to replace it with the value in the right side equation, wherever right side expression, wherever x is there, you'll replace with that value. Now the question is, I have f of x, I have g of x. If I ask you a question of what is f of g of x, then what I'm trying to do is, in the previous case, what is the difference between p of minus 2? In the p, can I change it as f now? Because you're knowledgeable in functions. So what is the difference between previous case and the case? What is the difference between this step and this step? So there we substituted value, and here you are substituting a function itself. So this is what is called as composition of functions. A function within a function is what is called as a composition of function. You're able to understand this? So we will look at it like a value, but have a different perspective. F of minus 2, I will say, I still substituted a function only. What function did I substitute? I substituted a constant function. That is a different way of presenting. Right? This is what you had been doing from your 9th standard. Right? So having this logic in mind, we will proceed with understanding of what is composition of function, and the next important step of what exactly is an invertible function. As I told you, this is the base for your inverse trigonometric function. So it is very important that you understand this. Okay. Now, if I give a definition to this, okay, I don't want to take the examples. Unnecessary confusion. I'll directly go to the definition part. You have one function which is defined from A to B. So A is the domain, B is the codomain. And you have another function G which is defined from B to C. So for you to define composition of function, the first step to be crossed is the codomain of the first function should be the domain of the second function. Okay. So F map from A to B and G map from B to C, B2 function. Then the composition of functions f and g is denoted as g circle f. Okay, it is denoted as g circle f or g of f of x. So g circle f of x, sorry, g circle f, or you can call it as g of f of x. They both mean. The next step will explain it. Okay, so it's called as g of f of x. Then you can define the g circle f from where to where? From A to C, where A is the domain of A and C is the codomain of G. Now you will understand. See, I start with the set A where you have the set of independent values, and you have another set B where by operating something, by applying a mission, you are able to create a function from this value x to the values in B, which we call it as f of x. Okay. From f of x, now f of x is the domain for whom? F of x is domain for the other operation g. So from f of x, if I perform an operation g, then how will I write that as? See, F is an operation. Right? What is that you wrote in the bracket? You wrote the domain values of f of x. That is x. Now for g, what will you write? You will write the domain values of g. What is the domain value of g? F of x. That is why it is g circle f of x, which is mapped from A to C directly. So to avoid the intermediate step, what you can do is you can create a connection like this, which is called as g circle x. Is that clear? This is what is composition of function. Okay. So please make a note of it. Those who are online here.
Yes.
Okay. So now we'll go to the next context. We'll see a problem based on it. Example number 15. Shall we start? I hope it is clear, right, for everyone. So f is a function mapped from 2, 3, 4, 5. Is that disturbing? Perfect. So f is mapped from 2, 3, 4, 5 to 3, 4, 5, 9. So domain is 2, 3, 4, 5. Codomain is 3, 4, 5, 9. G is a function mapped from 3, 4, 5, 9 to 7, 11, 15. The functions defined as f of 2 is 3, f of 3 is 4, f of 4 and f of 5 is 5. Okay, it's a many to one function. And g of 3 and g of 4 are 7. So g is also a many to one function. And g of 5 and g of 9 is equal to 11. Now our job is to find g circle f. That is, I need to find g of f of x. What are all the values of x that I can substitute? So g circle f of x is a function which is mapped from where to where, guys? So first, this condition is satisfied. If that is not satisfied, there is no composition at all. You can blindly say that composition is not possible. Okay. So g is a function mapped from 2, 3, 4, 5 to 7, 11, 15. Right. So I will start with g of f of 2, first number. So f of 2, I'll borrow it from here. F of 2 is equal to 3. So this is same as g of 3. G of 3, I'll borrow it from here. That is 7. Is 7 a part of this codomain? Yes, it is. Purida, in a similar way, can you do for the other three values? Do it fast. So what are the other values you need to find? G of f of 3, g of f of 4, g of f of 5. Do it fast and tell me. Got it? Huh? So all the three values should be somewhere between 7, 11, and 15 only. Correct? Huh? Okay. Now see. I hope no one has doubt in this. Going to the second one. Example number 16. Find g circle f and f circle g if f is a function mapped from real number to real number and g is also a function mapped from real number to real number given by f of x is equal to cos x, g of x is equal to 3x square. And they're asking you to prove that g circle f is not equal to f circle g. So what is g circle f? G of f of x. So do it fast. So g circle f is equal to g of f of x. So g is 3x square. So I'll write it as cos x square. So 3 cos square x is what is correct, Ada? 3 cos square x is right, no? So 3 cos square x is g of f of x. Then what about f circle g? That is f of g of x. That is cos of, see, f of cos, right, cos 3x square. You know, g of x 3x square, la? Correct? Akash, clear or not? So cos 3x square. So 3 cos square x is not the same as cos 3x square. That's it. Okay. Shall we try 17th one? No. The 17th one is the base for invertible functions. Okay. What we are going to do is we are seeing an example and then we'll try to understand what is an invertible function. Okay. Listen to this. This is a very, very important problem. Mark it. Okay. F is a function mapped from real number except 7 by 5 to real number except 3 by 5. Is defined as f of x is equal to 3x plus 4 by 5x minus 7. Right? How did they get real number minus 7 by 5? You look at the question, you will get that 5x minus 7 is not equal to 0, x is not equal to 7 by 5. Correct? How did they get r minus 3 by 5? Range. I told you certain steps, no? If you want, you can do it as an exercise. Follow the same steps. Find the domain of f of 5 that will come out as r minus 3 by 5. If you want, you can try and say it later. Okay. And see, that is not our context here. I'm just trying to explain it. Okay. And g is a function mapped from r minus 3 by 5 to r minus 7 by 5. So here one beautiful thing is happening. Observe in other problems what has happened. Especially the 15th problem, if you see, the codomain of f is the domain of g. But if you observe the domain of f and the range, the codomain of g, are they both the same? Domain of f in the 2, 3, 4, 5 and the codomain of g is 7, 11, 15. They both are not same. But look at this problem. No? What is happening? They are getting interchanged. That is the reason I told you this is the base for invertible functions. They get interchanged. Means the codomain will become domain and the vice versa. Given by g of x is equal to 7x plus 4 divided by 5x minus 3. Right? Is the question clear till this step? Right. Now what are they asking? Then f circle g is equal to IA, where I is called as an identity function, and g circle f is equal to IB. Okay, where A is equal to how much? R minus 3 by 5 and B is equal to R minus 7 by 5. This A and B is what they are trying to talk about. Okay, where IA of x is x for all values of x that belongs to the set A, and I of B is equal to x for all values of x that belongs to set B. So one thing that will confuse you is IA of x also I'm saying it as x. IB of x also I'm saying it as x. Is this confusing you? But what is it you need to concentrate on? See, IA of x, where does that x come from? X comes from the set A. How much? What is set A? Paranga question. R minus 3 by 5. R minus 3 by 5 and those values of x are coming. Whereas in the second case, those values come from R minus 7 by 5. Okay, that is why don't get carried out with x itself. See, this is actually a theoretical question. Are you able to understand? Is there any doubt in this? Any confusion? Any repetition needed? Perfect. So can I proceed? Procedure is simple. What are they asking? Simple thing only they are asking. Find f of g and find g of f. Can you do that? We'll try that. So what is the function? F of x over somebody from the having the textbook, please tell me. 3x plus 4 by 5x minus 7. G of x another 7x plus 4 by 5x minus 7. 5x minus 3. Okay, wow. Now see, what is g of f of x? So g of f of x is a function mapped from where to where? It is mapped from A to C. Right? So g of f of x, 7 into, in the place of x, what are you supposed to substitute? The whole f of x. So substituted 3x plus 4 by 5x minus 7 plus 4 divided by 5 into 3x plus 4 by 5x minus 7 minus 3. So yeah, so that will be 21x plus 28 plus 20x minus 28, the whole divided by 8. 15x plus 20 minus 15x plus 21. 15x, 15x, 28 and 28 will get cancelled. 42x divided by 42 is going to give you x. But where does this x come from? Where does this x come from? Is this not I of a or IA of x? Yes, it comes from a. Now the question makes sense. Now can you guys try out f of x, sorry, f of g of x and tell me the value? 2 minutes time, do it fast. X, where does that x come from? It comes from, okay. So remember this problem. Okay. What is it? Problem number 17. Is there anyone having problem? I mean, issue solving this on this x? Sandhya, you got it? What about you, ma? You got it? This guy. Shubham, got it? Monica? Vandada, you are saying for me. Vandada, you got it? Harshita? So everybody is clear with how these values have come. Just take that function and substitute in the place of x. That's it. Now the question is, so that's all with the problem. You're done with it. We'll see example number 18. Show that a function map from a to b and a function g map from b to c are 1 to 1. Then show that if, sorry, I missed it with. Show that if f map from a to b and g map from b to c are 1 to 1, then g circle f map from a to c is also 1 to 1. Okay. So if f is 1 to 1 and g is 1 to 1, what will you say? F of x1 is equal to f of x2. Then x1 is equal to x2. You know this fact, right? Now what are we supposed to do? You are going to follow the same steps. Let x1 comma x2, let x1 comma x2 belong to set A. What are we trying to prove for G circle F? Now, assuming G of f of x1 is equal to G of f of x2. Correct? So G of, since G is a 1-to-1 function, they told G is a 1-to-1 function in the question. G is 1-to-1 function. What should be the relation between f of, then the one which is inside the bracket, that is f of x1, should be equal to f of x2. But they told f is also a 1-to-1 function. Then what should happen? X1 should be equal to x2. What is the step with which we started? We started with g of f of x1 is equal to g of f of x2, and at last we got x1 is equal to x2. So what can we conclude? The G circle F is also a 1-to-1 function. Mark all these problems as important. They are very good. Okay. Try to solve them again. They're simple but important. Right. So if at all you have a function f map from a to b and g map from b to c, you say they are onto functions. Okay. Then prove that G circle F map from a to c is also an onto function. So how to solve this? So what is the condition for an onto function? F of x is equal to y for all values of y that belongs to the codomain set. F of x is equal to y for all values of y that belongs to the codomain set. So you start from the right hand side for onto function. That's what you do. In a similar way, If you take an arbitrary constant z that belongs to C, then there will exist a pre-image y of z under G. So what they are trying to say, you have F, you have G, right? So G, uh, this is X, this is Y, and this is Z. So all the values in set A, I call it as X, set B, I call it as Y, set C, I call it as Z. So for every for every element in the set C, which is Z, will there be a pre-image associated in set B? That is Y. Why? Because they already gave it's an onto function. Since G is an onto function, that should happen. In a similar way, what will happen? For every value of y that belongs to B, there is a pre-image associated with every value of y. Sorry, for every value of x that belongs to A. If that is the case, then G circle F is defined from where to where? G circle F is mapped from A to C. So can I directly say for every value of Z that is mapped from set C, there is a pre-image associated in set A. So that's all. It's the step that you need to write for. All the elements of the, they should know. I'll tell you what. So can you repeat the question to everyone? Can you be a little louder? Yes. Because it will not be a function. What is the condition for basic function? Leave about one-to-one or on-to. Every element in the domain should have some element associated. Correct? Now, you can ask me an import. So here there are two functions that are getting connected. X, the set of Y, and set of Z. Right? So for G circle F to exist, why we are saying the codomain here should be equal to the domain of that is because it should satisfy bijective function. I'll tell you why it is so. If I take x1, x2, so on, if x1 is mapped to some element here, I need to ensure that every element of set A is mapped to some element in set B, or else it is not a function at all. Let us assume that yn is a number which is not mapped. I can still call this f as a function. But for G circle F to exist, what should happen? This yn should be mapped to this. If it is not mapped, then it will not, then it is not going to be a function. Then is there a possibility that you can create a connection from here to here? Because yn is doing what? It is creating a break. That is the reason, that is a very important reason why we say for inverse of a function to exist, it should always be bijective. It should be one-to-one. At the same time, it should be on-to also. That's what we were about to read next, but you brought this question. You're able to understand? So this is also important. I hope you guys understood how to present it in the exam. Will you be able to do it? Yes. So shall we try 20th one? Consider the functions f and g such that the composition of function g circle f is defined and is one-to-one. Are f and g necessarily one-to-one? So consider two functions f and g such that you are able to define a composition of a function g circle f. Okay, and it is defined also. So f is a function mapped from where to where? A to B, and g is a function mapped from B to C. Okay, so when this is going to be the case, g circle f is a function mapped from A to C. Sharia. Now, if this is the case, they are saying that the composition, that is g circle f is one-to-one, that we have proved. But for this to exist, is it necessary that these two functions individually need to be one-to-one is what the question is. Think about it. So they have given an example. So if you consider a function f mapped from 1, 2, 3, 4 to a codomain 1, 2, 3, 4, 5, 6, defined as f of x is equal to x for all values of x, and g is a function mapped from 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4, 5, 6, where g of x is equal to x for x is equal to 1, 2, 3, 4, and g of 5 is equal to g of 6 is equal to 5. They have randomly assumed certain values, right? But for this, will you be able to write G circle F? Yes, you can still write it because the codomain of F is the domain of G. You can still write it. That is what they meant by exists. But in the process of you writing it, have you defined G as a one-to-one function? No, you didn't. But you ensured that G is a function. Means you exhausted all the elements present in the codomain, but you didn't ensure that every element has an image associated. What are the elements left out? So 1, 2, 3, 4 you have, 6 is not there. 6 is not used at all. So it is not a, it is not an onto function, that's a different story. But here it is not one-to-one because g of 5 and g of 6 are giving you the same value. So f might have been one-to-one. F, I don't know, they didn't define any function. F might have been one-to-one, but g in this context is not one-to-one, but still is the question satisfied? Are you able to define G circle F? Yes, you are able to do. So this is an important point to be noted. That is also possible. It's up to you. You consider a function of that sort. You consider a function of that sort. Yeah, it is. You're saying F is not one-to-one, huh? Okay.
But can X not be one-to-one?
Can F not be one-to-one? Yeah, that is also possible. No? You can define it the way you want. Because since the question is G circle F here, they wanted to take G into consideration. Had the question been about F circle G, they would have concentrated on F. That is the logic. Okay. 21st. Are F and G both necessarily onto if G circle F is onto? That's the same thing they're asking. Think about it. So consider the elements F map from 1 to 3, 4 to 1 to 3, 4. G is an element map from 1 to 3, 4 to 1 to 3. Defined as f of 1 is 1, f of 2 is 2, f of 3 is equal to f of 3 is equal to, sorry, f of 4 is equal to 3. And g of 1 is 1, g of 2 is 2, and g of 3 is equal to g of 4 is equal to 3. So what can you say from this? If you take G circle F, it might be onto, but G and F individually are not. Right. Okay. So you can make a note of these points. So having all these points in mind, I want to explain what is inverse of a function. Okay. So definition number 9, please write it down. Write the heading as inverse of a function. Okay. If you have a function mapped from x to y, okay, is defined to be invertible under what condition? If there exists another function g, which should be mapped exactly in the reverse order. I told you about the 17th problem, you remember? That's where the concept comes from. So if is a function mapped from x to y, and if you are having a function g which is mapped from y to x, such that if you are able to do the composition of both the functions g and f, that is g circle f is going to give you an identity function, and f circle g is also going to give you an identity function. But what is the difference in both the case? One is ix and the second is iy. So what does ix mean? So the domain of that function, where does that value of, the identity function is f of x is equal to x, right side should be x. Where does that x value come from? Come from x, capital X. Whereas f circle g is equal to identity function. It comes from y. It comes from set y. That is the meaning of it. Okay. So thus, if f needs to be invertible, then you need to ensure one important point. What is it? It should be one-to-one and onto. Conversely, what we can say is, if at all you have a bijective function, then you can always find the inverse of it. Okay. So this inverse is neither multiplicative inverse nor additive inverse. It has nothing of that sort. It's a function with respect to inverse. Sorry, it is inverse with respect to a function. That's it. You know what is additive inverse, right? So what is it? So what is additive inverse of 5? Minus 5. So why do you call it additive inverse? Because if you add that value, the output will be 0. What is multiplicative inverse of 5? 1 by 5. Because when you multiply both, it comes out to be 1. In a similar way, there if you see 1 and all those things, is it not identity or unit? In the same logic, if you take the composition of two functions and it gives you an identity function, you call it as an inverse function or invertible function. Okay. So having said this, let's try out example number 23. So there is a function that is mapped from natural number set to a set y, okay, which is defined as f of x is equal to 4x plus 3, where set y is what? Set y is, you will take only those natural numbers which satisfy what condition? Y is equal to 4x plus 3 for some x belongs to n. Okay, then you need to show that this function is invertible. Once you prove that it is invertible, show the inverse of this function. So for you to prove that it is invertible, the first thing is you need to show that it is 1 to 1 and 1 to 1. Do it fast. Yeah. So you could prove that it is 1 to 1 easily. So 4x1 plus 3 will be equal to 4x2 plus 3x1 will be equal to x2. Easy. What about onto? So for that you need to understand the codomain. So what does the codomain tell you? So codomain tells you y will be those values. What are they? 4x plus 3 for some values of x that belongs to n. When you put x is equal to 1, what will you get the value of y as? 7. When you put x is equal to 2, 11. So if you try to write that set, what will it be? 7, 11, then 15, something like that. You will have set of odd numbers kind of thing, but only few odd numbers, odd natural numbers. So I told you certain steps for onto function, right? So what will, so x will be equal to y minus 3 by 4. So what are the values of y that you're allowed to substitute? So you need not be 7. See, for example, y is nothing but 4x plus 3. 4x plus 3 minus 3 by 4. So what is it going to give you? Some x. So what is happening is that value is a natural number. So what I'm trying to say is, what is the domain of this function? It is, so x is equal to y minus 3 divided by 4. So try to understand this problem. For every value of y that you substitute here, what is it? You substitute 7, you substitute 11, you substitute 15, whatever you want, you substitute. There is always a natural number output that you will get. Correct? So that natural number set comes from where? From the domain. So what I can say is for all values of y that belongs to capital Y, there exists what? A pre-image from the natural number system. Hence it is onto. So one to one and onto both are satisfied. So it's clear. In this question, the trickiest part is what? The codomain. Is everyone clear, guys? Right? So there exists a pre-image in natural number set. That's it. So having said this, now we need to find the inverse of this function. So what is going to be the inverse of this function is same steps. So once you find same steps, you wrote x is equal to y minus 3, right? So can I call this as g of y? Can I say it as g of y? So g of y is equal to y minus 3 divided by 4. But what is y, guys? Y is f of x. So 4x plus 3 minus 3 divided by 4 is going to give you what? Oh, sorry. G of 4x plus 3 is going to give you what? It will give you 4x plus 3 minus 3 divided by 4, which is going to be x. And where is this x value coming from? For all values of x that belongs to natural numbers. That is the domain of f itself. Purida. Hence, it is an inversible function, and this is the inverse. So if this exists, then what you can say is, what is g of? So then I can say g is the inverse of f. Okay, then I can say g is inverse of f. When g of y is y minus 3, then what will g of x be? Sorry, x minus 3 by 4, and g of x will be x minus 3 by 4. Try to understand. So g of y is y minus 3 by 4. What is g of x then? So in the place of y, I am replacing it with x. So x minus 3 divided by 4. Okay. And this is what is called as f inverse of x. So in this context, so when you find g circle f of x, then g will be called as the inverse of x. If you find f circle g of f, then f will be called as the inverse of g. That is the meaning. So when you're doing g circle f of x, g is called as the inverse of x. If g circle f of x comes out to be x, identity function, then g is said to be the inverse of x. Then g circle f is equal to x for all values of x that belongs to set A, which is nothing but ix also. Then g is called as f inverse. If f circle g is equal to x, which is iy, then f is called as the inverse of g. So f is equal to g inverse, you can write. Okay. So for this exercise, you need little bit of knowledge about range also. Okay, we'll see. So let y is equal to n square, where n belongs to natural number set. Okay, it's a subset of natural number because n square, no, you will have only a square values of natural numbers, 1, 4, 9, something like that. Yeah. Consider a function map from natural number set to this set y. Okay, where f of n is equal to n square, then you need to show that f is invertible. Again, prove that it is 1 to 1 and 1. Then find the inverse of it. Can you try to just follow the same steps? First, try for 1 to 1. Are you getting 1 to 1? Check it. Don't look at that solution. Okay. So f of n is equal to n square. Now, what will be the first step for 1 to 1? Consider two elements n1, n2, which belongs to natural number set. So n1, n2 belongs to natural number. then what will be the next step? F of n1 is equal to f of n2. So n1 square will be equal to n2 square. Area. Then what will n1 be equal to? Plus or minus n2. What should you write that? Because natural numbers you don't have negative. So n1 is equal to n2. Hence it's a one-to-one function. Then what about onto? So first step, f of n is equal to y. F of n another. N square. F of n is equal to y. So n square is equal to y. Then what will be the value of n? Correct? Why? Because this is f of n is equal to y for all values of y that belongs to which set? Capital Y set. Hey, y belongs to which set? Capital Y. Capital Y another. N square. 1, 4, 9, something like this. So this is the set. Okay, n is equal to root y. So if you take the square root of, now tell me, in the place of y, if you substitute any value from y, will you be able to get a natural number again? Yes. So for all values of y that belongs to capital Y, there exists a pre-image. Hence it is it is an onto function. Done. Now what is the next step? Finding the inverse of it. So finding the inverse, range and onto function all follow the same steps. You never know. First step, n square is equal to y. N is equal to root y. So instead of x, you have n. We call it as g of y. This is equal to root y. So, but what is y according to us? N square. So g of n square is equal to square root of n square, which will give you n. So g of f of x is giving you n. Correct? G of, see if that n is confusing you, this is what is the actual meaning. G of f of x is equal to x. So g of f of n is equal to n. Now if that is the case, then this one, the g of y is there, no? The g of y is what is the inverse of f. Okay. So g of y is equal to root y. Then what will be g of x? They are the inverse. Okay. So g of x is inverse of this function is root x axis. Can we try one last problem? The slightly tricky concept. This is tricky and important. I want you all to read the question. Function map from natural number set to real number set be defined as f of x is equal to 4x square plus 12x plus 15. Show that you have the function map from natural set to some other set S. Where what does that set belong to? The set S belongs to the range of f. Prove that in this scenario f is invertible and find the inverse of it. So in which scenario is f invertible? Is it from natural number to R or natural number to S? Natural number to S is when the function is going to behave like an invertible function. For that, first it is our job to find the range of it. Okay, I'll help you out. Observe. Listen to this carefully. So, what is the question? 24th. Correct. To find the range, what did I say? Put y is equal to 4x square. That's the question. 4x square plus 12x plus 15. Find x in terms of y. So 4x square plus 12x plus 15 minus y is equal to 0. So what is this now? Previously it was a polynomial. Now it is a quadratic equation. So for quadratic equation, what is the solution? Minus b plus or minus square root of b square minus 4ac the whole divided by 8. b square minus b plus or minus root of b square minus 4ac divided by 2a. So minus 12 plus or minus square root of 144 minus 16 into 15 எவ்வளவு? Plus 16y, the whole divided by 8. So 240 minus 144, 196. 196, no? Sure, 196. Only 96. So minus 12 plus or minus root of 16y minus 96 divided by 8. Is it clear till this step? So what you have written here is x is equal to, I'll call it as g of y. Now what should you do? To find the range, so to find the range of f of x, find the domain of g of y. So domain of g of y, now see when will this function be defined? You have a square root. So that square root value should be greater than or equal to 0, which implies 16y minus 19 should be greater than or equal to 0. Actually, this is a direct step. So y should be greater than or equal to 6. So what is the range? So natural number to 6 to infinity. Just a minute. Y is greater than or equal to 6. Right. I hope the steps are clear, right? Now what is our job? In this case, you need to prove that it is invertible. So for that, what you need to do? Will you be able to prove that it is 1 to 1? Will you be able to do it? I'll tell you how to do it. x1 comma x2 belongs to natural number set. So 4x1 square plus 12x1 plus 15 is equal to 4x2 square plus 12x2 plus 15. 15 are gone. Bring 4 to the other side. So 4 into x1 minus x2 into x1 plus x2 is equal to 12 into x2 minus x. Yeah, I can do that. I'll take the minus sign outside, or I'll bring this 12 itself to this side. Then it will be something like this. Correct? Then if I take 4 into x1 minus x2 outside, x1 plus x2 minus 1. Correct? Since x1 and x2 belong to natural numbers, so minus of minus 1. Oh, this plus then plus then x1 minus x2. Correct? Noda, 12 is here. This x2 I bring it this side. 12 into x1 minus x2. Observe that 12x1. That I changed. Yeah. So x1 plus x2 plus 1. So x1 and x2 belong to natural number set plus 1. So sum of positive numbers can never be 0. And 4 is also there. From this, what can I conclude? x1 minus x2 should be 0. From this, I can say x1 is equal to x2. So this kind of a problem, you need to go with this method. I hope you're clear with the steps. Right. So for onto function, now will you be able to say? For onto function, you have already found the range. Now that range is equal to codomain already. You found the range, y is greater than or equal to 6. So any value of y greater than or equal to 6, you are going to substitute here. What you are going to get is a natural number. Right. When that is going to be the scenario, then codomain is equal to range. It is already an onto function. Now you need to find the inverse of that function. How you find it? So for inverse of the function, I told you, right? Go to the g of y. So what is g of y? Minus 12 plus or minus 16 y minus 96 by 8 okay, right. Then what is going to be the inverse? So g of y is this value, then what is g of x? G of x, just replace y with x, that's it. Minus 12 plus or minus root of 16x minus 96 divided by 8. That is going to be the answer. But I'm not sure why they have not given you the inverse. So actually what you can do, take the 16 out. It will become 4 into root of y minus 6 divided by something. Okay. So g of y, see what I'm going to do is minus 12 plus or minus. Can I write it as 4 into root of y minus 6, the whole divided by 8. So this 3 times, this will go 2 times. So I'll have root of y minus 6 plus or minus root of y minus 6 minus 3, the whole divided by 2. Then what is the least value of y that you can substitute? So here the negative values are supposed to be removed, right? So it is going to be root of y minus 6 minus 3 divided by 2. This is what is g of y. Then what will be the value of g of x? Root x minus 6 minus 3 divided by 2. So in your textbook, they have not given you the inverse. If you take this and substitute it in f of g of x, you will get the answer as x. Okay. So this is all about inverse. This is all about the inverse of a function. Then what we are supposed to do is, what will happen if you have 3 functions taken into consideration? That's a very simple thing again. Okay. But otherwise, are you guys able to get a hold of what is inverse of a function? Slowly you will understand. You have to practice it. Okay. Is there any doubt you have? Not, think about it. Practice it and come. So tomorrow's class we will start the exercise problems and then we'll complete it tomorrow. So once that is done, right, inverse trigonometry is not this complicated. So going forward, it will be easier. This is the only chapter which is actually tough. That is why most of the schools don't start. But if you're able to master this chapter, other chapters are easier. So yeah, try it out. That's it. Any other doubts? That's it? Okay. Then we can wind up this. The image. X, or I will say 1, 2. Okay. If I say 1 is mapped to 2, 2 is the image of 1, 1 is the pre-image of 2. That's it. Okay. Okay. Those who are online, any doubt, guys?
No, sir.
Okay. Harini and Hamsini, clear?
Yes, sir.
Okay, good. So keep
Sir,
practicing.
will you discuss assignment problems tomorrow, sir?
Yeah, we'll discuss it tomorrow. Once this exercise is over, we'll discuss it. Okay.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.
Thank you, sir.